Hello everyone, welcome you all to another random tutorial. So I am Sineth. So today we are going to implement an A to Z and 0 to 9 character recognition, handwritten character recognition crop tool using Python and related modules such as Keras, Tensorflow, OpenCV and Numpy. So before moving to the tutorial, I would like to tell you that if you are interested in machine learning, deep learning, computer vision or image processing or any of the related field regarding to computer science or software engineering, so please subscribe to my channel and hit on the bell icon. I am planning to do several kind of interesting tutorials and project reviews throughout my channel. So let's get started with the project overview now. So I think you have seen the demonstration program video clip which I have already embedded in the beginning of this video, right? So otherwise you will not be able to understand the basic functionalities and the project architecture and the behaviors of our application, right? I think you have seen demonstration program. So let's get started with the project overview. So as you all know that our application contains a whiteboard, right? Inside that whiteboard we can draw any character, anything using our mouse pointer, right? So think this as a drawn character whiteboard. So there is a function in our application to crop down any interested region from our whiteboard, right? So we have cropped down a character from this drawn character whiteboard. So whenever you have cropped a character from the whiteboard, it is going to be inverted, right? So what is the purpose of inversion? So inversion means that it is going to be it is going to be swapped background color and the foreground color of the cropped image, right? So you can see that whenever our cropped image background color is white and the foreground color is black, whenever we have inverted this image, the resultant image background color is black and the foreground color is white. So that's the goal of color inversion of our cropped image. Then we have to convert our cropped image into the resolution of 28 and 28, which means we have to scale our cropped image. Then that pre-processed image is going to be passed to a trained convolutional neural network. So convolutional neural network is a type of neural network which we can identify in deep learning concept. So most of the time convolutional neural networks are used for image related problems and also image classification and also image processing problems related to deep learning, right? So what we are going to do is we are going to pass our cropped character to the trained convolutional neural network. So our convolutional neural network will able to give us predictions regarding to our input image. From those predictions, there are in our application there is a mechanism to find out the best prediction from the output of convolutional neural network, right? So from the output, this mechanism is going to capture the most accurate tree predictions, which also called as best tree predictions, and return as the output of this mechanism. So you can see there are three predictions, namely first, second and third. So each prediction contains a predicted label and the respected accuracy related to the prediction, right? So that's all about the brief overview regarding to our project. So let's move into the desired output. So I think you have seen this desired output from the demonstration program. So as I previously mentioned, there is a whiteboard in our application. So this blue color region represents the whiteboard region. So we can draw anything inside this whiteboard using our mouse pointer. By the way, we can also clear out and we can also erase anything any drawn character from our mouse pointer also. So if you want to draw something on this whiteboard, you can use left button. So if you want to clear out some specific region in this whiteboard, so you have to press right button and move your cursor, right? So if you want to clear out all the region of your whiteboard, so you have to simply press your character E simple E, then your all the whiteboard will be erased, right? Okay, so the yellow color region represents the status panel of our application. So you can see that the status panel is for to visualize the current status and the behaviors regarding to our application. So you can see in the top there is a label called action. So action describes about the current action or the current function which we are engaging with. So you can see that the current action is crop, which means that we are our mode is has converted into the crop, right? So as an example, so if you want to draw something in the whiteboard, so you have to convert your action into draw mode, right? So if you want to crop something from the whiteboard, so you have to switch your action to crop mode, otherwise you will not be able to crop something from the whiteboard. So like that, if you want to do image drawing or image cropping from the whiteboard, so you have to shift from draw and crop actions. So while you are switching between those actions, the action label is already is also going to be updated, right? So in this particular white border region is represents the visualizing the inverted image which you have already cropped, right? So that inverted image is going to be visualized in this region, and this table describing the best predictions which our functionality has calculated throughout the output of our convolutional neural network. So the red color row represents the most accurate prediction, right? This green color row represents the more accurate prediction, and the blue color represents the accurate prediction among of three predictions, and their respected accuracies can be seen in the accuracy column, and also their related labels can be seen through the prediction column, right? Likewise, we can identify the features of our desired output. So let us move on to the data pre-processing, right? So I have imported several kind of packages for my data pre-processing purposes. So if you haven't installed any of the package which I have already imported in this cell, so you can simply download and install all the packages to your computer by Python package installer, which also called as pip. So before moving to the implementations regarding to data pre-processing, I will explain you about what we are going to do throughout the data pre-processing, right? So as I previously mentioned, our application should be able to classify both A to Z handwritten characters and 0 to 9 digit characters, right? For that purpose, we should have two datasets of A to Z handwritten characters and 0 to 9 digit characters, right? So we are using Kaggle A to Z handwritten dataset, which is mostly commonly used dataset in different kind of real world applications also. So we are using that dataset for our A to Z English letter dataset, and we are using MNIST dataset of Keras as the 0 to 9 handwritten digit dataset. So what we are going to do with these two digit dataset is that we are going to merge those two digit datasets and have one particular individual dataset, right? Then we are going to fed that particular dataset into our convolutional neural network. Then we are going to train our convolutional neural network and pick out the best trained convolutional neural network and use for our applications predicting purposes and the overall functions, right? That's all about our data pre-processing and the further upcoming functions. So as I previously mentioned, we should have two datasets for A to Z handwritten letters and also 0 to 9 handwritten digits. So I used Kaggle A to Z handwritten dataset. So if you want to download that Kaggle A to Z handwritten dataset, so you can go through the references and refer the first link which I have mentioned in here to download the A to Z Kaggle dataset, right? So you can simply download, and it is actually CSV file, so you can simply download that CSV file. So I have mentioned to you that we are using MNIST dataset of Keras as our 0 to 9 handwritten digit datasets. So using keras.datasets we can import MNIST dataset. So if you haven't installed your downloaded MNIST dataset through Keras, so there's nothing to worry. So you can simply tell mnist.load data. If you haven't downloaded your MNIST dataset, so it will be downloaded from the company, from the internet, and load to your application, right? So, and if you prefer to download MNIST dataset from explicitly, which means if you want to download MNIST dataset manually towards the internet, so you can refer the second link, MNIST datasets. So you will be able to download MNIST dataset separately instead of Keras library, right? So this is the path which I have saved my A to Z handwritten dataset. So I have since it is a CSV file, I am using pandas library to read my A to Z character dataset in the type of float 32. So in my A to Z English character dataset, there are about 785 columns for each particular image. So the first column is representing the label, and the rest of the 784 columns representing the features of each image, which are pixels, right? So each image there are about 784 pixels, which means flattened row of pixels for each image. Then we are going to do is we are going to separate both labels and the pixels of each image and do our implementations, right? So we have read our CSV file and pass it to the dataset. Then what we have done through this line is that we have renamed our 0th column of dataset as label, right? Okay, then what we have done is that we have dropped label and captured the rest of 784 pixels of each image and passed it to the letter X. Then I have captured the label of the dataset and passed it to the letter Y, which represents, so you can see that X and Y representing both data and target of A to Z handwritten letters, right? Okay, then I have downloaded and loaded my MNIST dataset. Then I have passed my values of my letter X, values of my data to letter X, right? Then I have print out the shape of my letter and digit dataset. So you can see there are about 372,450 images for A to Z handwritten characters, and there are about 784 features for each image and their related labels. And there are about 60,000 trained images of size 28 and 28 and their related labels for train segment of digit datasets, and there are about 10,000 images of size 28 and 28 and their related labels as the test segment of my digit dataset. Then I have concatenated both digit train and digit test and have it to a digit data, which means I have concatenated train and test splits of my digit datasets and have a single dataset which representing the overall digit dataset. So overall, as the overall, my digit dataset contains 70,000 images of size 28 and 28 and their related labels. Then I have added 26 to my digit target. So I previously told you that our goal is to merge our letter and digit dataset and have a one dataset. So to address our labels individually, I have to I have to add 26 to my digit target, which means that from 0 to 26 there are about from 0 to 26 the labels is for the characters, A to Z characters, right, A to Z handwritten letters. From 26 to onwards the label should be addressed for digits. So for that purpose I am going to add 26 to my labels of digit data set. Then I have looped through each and every features of images of A to Z handwritten dataset. So you can see that I have looped through each and every 784 pixel vector of my letter X, and I have assigned it to a flatten in each time. Then I have reshaped that flatten 784 flattened pixels to 28 and 28 and 1 shape using numpy.reshape. That rescaled image is going to be append to data list. For after the execution of this loop, my data list is going to be converted as a numpy array in the type of float 32. Then my label of A to Z handwritten dataset is going to be assigned to letter target. Then in the next cell I have reshaped digit data as a 4-dimensional array, right? So I have used numpy.reshape and passed digit data and passed the related sizes. At the end I will be able to have my digit data in the 4-dimensional manner. So you can see that both of letter and digit data portions have converted into 4-dimensional manner. Then I have shuffled my letter data and randomly picked 100 images from my A to Z handwritten characters. Then I have plotted all those 100 images using matplotlib library, right? Then you can see that there are about 100 images which representing A to Z handwritten characters, right? Then same thing applies for digit data. I have shuffled digit data and plotted down 100 images randomly, so you can see that. Then I have concatenated my digit dataset and letter dataset, right? Then I have one data and target, which means I have one particular individual dataset which is going to be fed into my desired convolutional neural network, right? So you can see that overall in my merged dataset contains about 4,42,450 data points in the size of 28, 28, 1, and they are related labels. So our ultimate goal regarding to data preprocessing is to merge those two datasets. Then we have merged our both letter and digit datasets, and we remain with one particular dataset to be fed into our convolutional neural network. Then I have shuffled my dataset and plotted down 100 random images. I have picked 100 images from my dataset and plotted using matplotlib library. So you can see that the plotted image from the plotted images, so you can see that most of the images are, there is a mixture of both A to Z characters and 0 to 9 digits. So there is A, there is 3, there is S, and there is 9. Likewise, you can see a mixture of letter dataset and digit dataset can be seen through the merged dataset, right? Then I have split my merged dataset into train and test as train and test splits. So I have used train test split function. Then I have passed my data and target, and I have specified my test size as 0.3, which means that from data and target, right, from data and target, it is going to be allocate 20% of data and target as test data and test labels. So the rest of 80 data and target will be assigned as train data and train labels. So before moving to convolutional neural network, we should have a training data segment and also validation data segment, so that we have to split our overall dataset into train and test bits. So likewise, after the successful execution of this cell, we will be able to have both train and test splits regarding to our dataset. So you can see that there are about 3,53,960 train images of size 28, 28 and 1 and their related labels, and there is about 88,490 test data and their related test labels. Then in the next cell, what we have done is we have normalized each pixel in our train data and test data by dividing it by 255. So dividing 255 means we are going to normalize each pixel in train data and test data in the range of 0 to 1, right? Then I have categorized, I have converted train labels and test labels to the categorical formation. So since our convolutional neural network accepts only the labels of categorical format, so we have to convert our train labels and test labels to the categorical formation. Then we will end up with categorized train labels and test labels. Then we have to convert our train data and test data into 4-dimensional array, right? So you can see that our train data and test data has already converted into 4-dimensional array, and each label of train and test splits has have converted into categorical formation. So you can see there is about 36 amount of labels, right? So which means that 26 of letters, 26 of A to Z letters, and 10 amount of 10 labels for 0 to 9 digits. So within the addition of 26 plus 10, which is 36. So 36 means that overall number of labels is 36, and their related train and test labels can be seen throughout this result, right? So in these two cells, what I have done is that I have represented my train and test data distribution throughout a chart. So you can I have used matplotlib to generate this chart. So you can see that x-axis represent for the frequency, and the y-axis represents for x-axis represent for the character, and the y-axis represent for the frequency. So the blue color bars stand for train data, right? Okay, so the blue color bars representing train data, and the red color bars representing the test data. As you can see that from 0 to 9, the distribution of the characters is almost nearly equal, which means that we have the data distribution of MNIST dataset is actually nearly equal. So likewise, we can see that from 0 to 9, the data distribution is nearly equal. The majority is for majority frequency has given for the character 0, right? It is the majority distribution, right? Majority of the distribution. So the least amount of distribution is for the character I, right? Likewise, we can have a brief idea about the train and test data distribution regarding to our train test split, right? Then finally, what I have done is that I have saved my train data, train labels, test data and test labels to my local machine as numpy files. To do that, I have used numpy.save function. So I have to pass firstly I have to pass the path of my path for my file, and then I have to pass the array, numpy array. Then that numpy array will be converted into a file and will be saved to my computer storage, right? So likewise, I have saved all train data, train labels, and test data and test labels to my computer as numpy files, right? That's all about data preprocessing. I think you have a considerable knowledge regarding to data preprocessing and the stuffs which I have talked throughout the data preprocessing. So our next section is convolutional neural network architecture. So let's move into convolutional neural network architecture and train our desired convolutional neural network. Okay, let's get started with convolutional neural network architecture. So I have imported several models which we are using for the convolutional neural network architecture implementation. So if you haven't installed any of the mentioned models, so you can download and install them using Python installer package, which is also called as pip. In the next cell I have loaded train data, test data, train labels and test labels, which I have already saved to a numpy file in the data preprocessing. So I have load those every data and label sections, label segments. Then we can see that this is our convolutional neural network architecture. So our the model of our convolutional neural network is sequential. So the first layer is a 2D convolution layer of 32 convolutions of size 5 by 5, and our input shape is 28, 28 and 1, which means 28, 28 resoluted grayscale image. Then we have passed activation as value activation functions. Then I have added a batch normalization as the next layer. Then in the second convolution layer, there's also about 32 convolution of size 5 by 5, and our activation is relu. Then have added another batch normalization layer. Then have added a max pooling 2D max pooling layer of pool size 2 by 2, and have added a dropout layer of 0.25 dropout probability to avoid from overfitting problems. Then in the next layer, I have added another batch normalization, and I have added a flatten layer to flatten every output from the batch normalization layer, right? So then I have added a dense layer of 256 neurons. The activation of our dense layer is relu, right? So as the output dense layer, I have added 36 neurons, so which means the output layers, the number of neurons in the output layer should be equal to the number of labels from our convolutional neural network. So as we seen in the previous data preprocessing, there are about 36 labels which we have to be predicted, so such that we have to add 36 neurons as the output layer, and our activation function is softmax, right? So in a particular convolutional neural network, there are two sections, right? The first section is for feature extraction, and the next section is for image classification, if not the classification, right? So not image classification, it is for classification, right? So this bunch of layers are eligible for the feature extraction purposes, and these layers are eligible for classification purposes, right? So both of these feature extraction and classification layers are combined and form our overall convolutional neural network, right? Then I have compiled my model with the loss function of categorical cross entropy, right, which is most commonly used for the classification problems. Then I have passed Adam optimizer as my optimizer. Then I have passed accuracy, such that because I want to monitor accuracy whenever my model is going to be trained, right? Then I have print out the summary of my model, right? Okay, you can see that about the summary. So you can see there are about 3,200 neurons in flattened image, and there are about 8,55,000 total parameters, and trainable parameters of 8,55,364, and there are about 192 non-trainable parameters, right? Then in the next cell, you can see that I have represented my my neural network as visually, right? So to represent any neural network visually, we can use visual Keras model. So if you haven't installed visual Keras, you can go through this command and simply download and install visual Keras. So we can pass model to our layered view function of Visual Keras, so you will be able to get the pictorial representation of your convolutional neural network like this, right? In the next cell I have added 2 checkpoints, right? So what is the purpose of checkpoints means that whenever my model is going to be trained, whenever I have a minimum loss model, right, whenever I have a minimum validation loss model, so I should be able to save my model to my local machine, right? It will be my best model, right? So like that, whenever I have a best model regarding to minimum loss or minimum validation loss, so I have to be save that model to my local machine. So to do that, I have added 2 checkpoints which representing one for minimum validation loss, the next one for first one for minimum loss, the next one for minimum validation loss. Then I have passed file paths for both 2 loss models, right? Then I have passed mod as minimum for both 2 models, and I am interested in only the weights, so I have passed save weights only. I have true the state of save weights only to save the weights, save only the weights during this save in progress of respected models, right? Such that I have mentioned 2 checkpoints. So in the next section, what we have done is that we have trained our model with model.fit function. So I have passed train data and train labels, right? So those are our preprocessed data which we have saved to a numpy file, as I think you will remember, right? So the validation data, I have passed test data and test labels for the validation data. So I am going to train my model with not 20, I am going to train my model with 10 epochs, and my batch size is 200, which means each step of each epoch, right, each step of every epoch, there are about 200 randomly picked images is going to be fed to my model, right? So the batch size representing that, right? So it is going to get randomly picked 200 images from trained data in each step of every epoch, right? Then I have passed my 2 checkpoints, which is representing best loss and best validation loss. So these 2 checkpoints will be able to capture the minimum loss or the minimum validation loss of trained model, and find the best minimum loss model or find the best minimum validation loss model and getting to be saved to my local machine, right? Likewise, we can train our model by passing these parameters, passing these arguments to model.fit function. Then we will be able to get the history regarding to the overall training progress, right? And you can see that my model has been trained within 10 epochs. So you can see that this is the minimum validation loss epoch which we have got. So you can see that the minimum validation loss is about 0.03 and validation accuracy is about 0.99, which is very close to 100%. So you can see that everything is okay. I think my validation loss checkpoint will be able to save this the model which is created in this epoch to my local machine as H5 file within the weights, right? So in the next section, you can see that I have plotted both loss and validation loss which have created during the training progress by passing history. History mean this one, which means to get the overall historical outputs from the model training phase. So I am going to get history loss, which means the loss distribution and the validation loss distribution, and plotted them using matplotlib, and you will be end up with this data distribution, loss and validation loss distribution, right? Okay, in the next you can see that I have followed the same procedure to plot accuracy and validation accuracy using matplotlib. So you can identify the accuracies are gradually increasing and the losses are going to be gradually decreased, right? Then I have logged the weights of my best validation loss model, which has already been saved after the training execution. So I have logged weights of my best validation loss model to my model. Then I have evaluate my model by passing test data and test labels. Then I will be end up with loss and accuracy related to the evaluation. So you can see that 0.039 loss has been created by the evaluation, and 0.99 accuracy has been created also. Then I have predict my model by passing test data. Then I will be end up with the predictions. Then I have passed my test labels and the predictions to a confusion matrix. Then I will be able to get the confusion matrix regarding to my predictions and also the test labels, right? So the confusion matrix is a matrix which we can use to identify the conflicts, right, and the relationship between actual and predicted labels of the output of the predictions, right? We can pass predictions and the actual labels and the predictions regarding to those actual labels. Then we can find out the relationship between the predictions and also the actual labels, right? Then we will be able to identify different kind of conflicts regarding the predictions and test labels, right? So instead of printing the confusion matrix using print function, I was preferred to plot this confusion matrix using matplotlib, right? So you can see that this is our confusion matrix, right? So it is somewhat large. Then okay, let's go with this size, right? So you can see that actually the distribution is quite very good within comparison between actual and predicted labels. So you can see there are small amount of conflicts regarding to the sometimes there is some kind of small amount of conflicts we can identify throughout the relationships, but as the overall idea, it has given a good predictions regarding to actuals, and the relationship is considerably good, and we can go through this model successfully, and there we can expect good results and best results from this model, right? Okay, it's all about convolutional neural network architecture. So let us move into the application implementation now. Okay, let's get started with real-time applications implementation. So until now we have seen data pre-processing and convolutional neural network sections. So this is our last sections regarding to our today's tutorial. So let's get started with the implementations. So by the way, before moving to the implementations, I have to tell you some special thing. So it is about that you can see that there are a lot of code parts which we have to talk through this section, but I am not going to talk each and every section deeply, so otherwise we will be able to consume lot of amount of time, so and also it will be little bit boring, right? So as a solution for that, I am going to explain each and every function or each and every code segment as abstractly and in brief manner, so you will be able to get the summarized idea about the functions and those respected bunch of codes, right? So I have imported my related modules as usual. So you can see I have import OpenCV library, Numpy, and the related modules such as related modules to Keras models and Keras layers which we will be used as the packages for convolutional neural network. Then there is a function called clear whiteboard. So we have to pass a display, then it will be clear out our whiteboard. So I have told you that our application, throughout our application, we will be able to draw anything on the whiteboard. So and also we will have chance to clear out anything which we have drawn previously, right? So to clear out our whiteboard entirely, or clear out our whiteboard, clear out some specific region from our whiteboard, so we can use clear whiteboard method. So we have to pass the display, right? So the display means display is the combination of both whiteboard and the status panel. So both whiteboard and the status panel is combinationally referred as the display. So we have to pass display, then our whiteboard will be cleared by executing this function. The next function is setup display. So this setup display function is for to set up the specific labels and specific rectangles, specific lines, and different kind of setup purposes of our display. So whenever we call this setup display function, it will be going to create a whiteboard, create a status panel, and create a title bar, and merge them all and draw rectangles on the display, and draw several lines, right? Draw and draw in different kind of text which you have identified, such as action, based predictions, prediction, accuracy, like terms, and also it is going to concatenate both whiteboard and the panel, and also the title, and have overall display, and it is going to be return the display as the output of this setup display function, right? Okay, the setup panel function is for to set up the panel's status. So you can see that if you want to draw down, or if you want to put the action which you are currently engaged in, so you have to update this action region. So if you want to visualize the inverted image, so you have to update the inverted image region. Likewise, you have to work with the different behaviors and different states of this panel. So whenever you need to set up the panel by updating different kind of states, so you can simply call setup panel function and pass display, and then the display will be updated, and especially the panel region of the display will be updated, right? Okay, then there is a function called arrange crop rectangle coordinates. So this function, there is a hidden logic which I have implemented throughout this function. So I will explain you about that using my Windows desktop. So as I previously mentioned to you, that our application, by using our application, we will be able to crop out any interested region from our whiteboard. So our crop panel work similar to this our Windows desktop select rectangle. So whenever we need to crop something, we can draw a rectangle like this, and we can get the cropped image, right? So we have to draw a rectangle like this, right, to identify the selected region when we are cropping something. So to draw that rectangle, we have to identify the coordinates of this rectangle by considering the mouse pointer and different kind of coordinates, and after identifying those coordinates only, we will be able to draw a filled rectangle like this, right? So to do that, I have implemented arrange crop rectangle coordinates. So this function will give me the arrange coordinates to draw to draw the cropped rectangle on my whiteboard. So it will give me the arrange code. It will check in some kind of conditions, and according to the conditions it is going to arrange my coordinates, and it is going to return results as the arranged coordinates of as the outputs of this function, right? Then this mouse click event function is to identify the events, right? So I previously told you that we can do several things using our mouse pointer. So whenever we engage with mouse, it is going to listen about our mouse state, and according to mouse state it is going to do several actions. So if you want to draw something, then it will be listened by this mouse click event function. Then it is going to it will give you the chance to draw on the whiteboard. So if you want to erase something on the whiteboard, so it is going to first listen on your mouse, then it is going to give you the chance to erase on the whiteboard, right? Then the function is whiteboard draw. So whenever you need to draw something on the whiteboard, you can call this function, and whenever you need to crop something from the whiteboard, so you can simply call this character crop function. Then it will be the selected region will be cropped, and you can whenever you need to get the prediction of these get the prediction of the crop image, so you have to you can invert the crop image and pass to the predict function. Then it will you can get the best predictions, and you can preview those predictions throughout the panel also. This load model function is to load the weights of our model and set our model and return our model as the output, right? You can see that our the neural network which we have implemented through the second section. So this is our convolutional neural network. Then we have load weights to our model. So the parts of our load weight file is passed as the argument to the sorry about that argument to the load model function. Then that the weights of that path is going to be read and passed to the model function. Then the predict function is eligible to get the prediction, right? Get the predictions mean get the best 3 prediction from according to the output of the convolutional neural network. So you can see that we have passed our model and the image. So the model the image is going to be passed to the model. Then model is giving us several predictions. So among of those predictions, we are going to pick out most 3 accurate predictions, which means best 3 predictions, and passed as the output of that function, right? So these are some kind of variables which are maintaining the states of our overall applications. So you can see that these are global applications. So these global variables can be changed and can be reallocated inside the inside the functions which we have talked so far, right? So this is the main entry point of our function, right? This is the main entry point which the application is going to be started, right? And the common things happen in this section. So you can see that there is some important thing you have to identify in here is that you can see that we are capturing the keyboard characters such as D, C, E, right? So which means that if you want to draw something on the whiteboard, so you have to simply press simple D of your keyboard. If you want to crop something from your whiteboard, you have to simply press C character of your whiteboard. And also if you want to clear out your whiteboard entirely, so you have to press E, then your whiteboard will be clear out entirely, right? Okay, so let's have see, let's going to let us okay, let us get started with our application. So I'm going to run out my application. So okay, okay, I think okay, give me some time. Oops. Okay, right. Let's run our all the code sections from the beginning. So I'm going to execute all the cells, right? I have executed all the cells, so the application will be started after some time. Uh-oh. Okay, now you can see our application, right? So everything is okay. So if I want to draw something on the something on the whiteboard, so you can see the action is not allocated, which means there's no action, neither draw nor crop, right? There's no any action, so I have to change my action to draw anything from the anything on the whiteboard. So I am pressing D, so you can see the action is transferred to draw mode, so I can draw anything. So I am drawing some random characters here, 6, then what else, F, then G, then B, then W, then U and Q, like thing, right? I have drawn different characters. Then I want to activate my crop tool, so I am pressing C. Then you can see my action has converted into the crop mode. Then I will be able to crop a character, right? So I have cropped a character. Whenever I released my mouse pointer, so the image is going to be inverted, and the predictions can be visualized throughout this table, right? So you can see this is our inverted image. So this is the best predictions table. So you can see the first it is give us the 100 accuracy from the first label, right? So I want to crop another character, so you can see gives as F, right? You can see there are two predictions. The first prediction is for 6 and it is about 0.7, which means 70% accuracy, and it is telling the cropped image as F, and the accuracy is about 0.3. Likewise, so we can crop any character. So it is telling that it has 8, I think, yeah. Now it is telling that it has B. So the prediction is also depends on the way which we are cropping the characters, right? So note that also, like thing, right? Likewise, we can crop any character, so then we can have the predictions regarding to our trained convolutional neural network. Okay, that's all about our today's tutorial. So I think we have covered a lot, right? Actually we have covered a lot. We have first gone through the data pre-processing. As in the next, we have gone through the convolutional neural network, and finally we have successfully gone through the real-time applications implementations. So that's the end of our tutorial for today. So if you guys really enjoyed today's tutorial, so if you have any doubt, so if you have any question regarding to our tutorial, so please let me to know about your doubts by mentioning your questions and doubts in the comment section. So and also I will upload these all the materials regarding to our today's tutorial, and I will be drop several links to download your application, to download those all the materials in the description, right, the below description. So if you guys have any suggestion and any idea related to my the quality of my contents and the anything regarding to my channel, so please keep them also in the comment section, and I am very happy to consider your suggestions and improve my further upcoming contents also. So thank you very much again. So let's meet with another random tutorial, and keep learning and stay safe. Thank you.